Welcome to today's math session. In this lesson, we are going to tackle some interesting problems involving modulus function, also known as absolute value function. These types of equations are common in O-level and IGCSE Additional Mathematics. So let's strengthen your understanding with some clear explanations and examples. The modulus of a number is the magnitude of a number without a sign attached. In other words, you can say it's the distance from 0. Like if we draw a number line, here it is 0, it's 1, it's 2, it's 3, it's 4 here. On this side, there are negative numbers. -1, -2, -3, and minus. The distance from 0 is 4 on both the sides. Here it is 4, and same is the case on this side. The distance from 0 till 4 is 4. The modulus of 4 is written as, we write these two straight lines, and within that there is 4. Now, modulus of positive number is 4 and modulus of negative number is 4. The distance from 0 till 4 is 4 and 0 till -4 is 4, which is represented over here. Whether there is a positive sign or a negative sign within the absolute sign, the absolute value is positive. It is important to note that the modulus of any number, positive or negative, is always a positive number. The modulus of a number is also called the absolute value. Modulus of x equal to x if x is greater than 0. Modulus of x is 0 if x is equal to 0. Modulus of x is minus x if x is less than 0. Now we will solve some equations related to absolute function equations. We have absolute of 6 minus 5x is equal to 2. Whenever you have absolute value equation, you will write 6 minus 5x is equal to 2 or 6 minus 5x is equal to minus 2. Because either the value of this is equal to 2 or the value of this is equal to minus 2. That's why there is 2 here. Now we will solve this equation in the same way as we solve ordinary equations. Minus 5x is equal to minus 4. 5x is equal to 4 and x is equal to 4 upon 5. In the same way, we can solve this equation. Minus 5x is equal to minus 8. We have 5x is equal to 8. X is equal to 8 upon 5. Once you have taken out the values of x, you have to check as well. Now we will substitute these values in this equation so that we can check whether it is satisfying the equation or not. So we have here 5 and 5 cancel. 6 minus 4, 2. So absolute of 2 is equal to 2, which is correct. We will substitute 8 upon 5 as well. 6 minus 5 into 8 upon 5 is equal to 2. So here 5 and 5 cancelled out. 6 minus 8 is minus 2. Absolute value of minus 2 is 2. Another question in which we have to solve x plus absolute of x minus 5 is equal to 8. Make sure on one side of the equation there is absolute value function and another side there are numbers without absolute sign. So first of all, we will take x on that side. So it will become x minus 5 with an absolute sign is equal to 8 minus x. Now we will write x minus 5 is equal to 8 minus x, and x minus 5 is equal to minus 8 plus x. Once we will write with the same signs, another time we will change the sign of both the terms. So we will take this x on this side, so it will become 2x. 8 plus 5 will become 13. So x is equal to 13 upon 2, which is equal to 6.5. When we will take x here, it will become x minus x. And minus 8 plus 5 will become minus 3. We cannot solve it further because x minus x will become 0, which is not equal to minus 3. We will check this value by substituting in the equation whether it is satisfying the equation or not. So 6.5 plus an absolute sign 6.5 minus 5 is equal to 8. So we have here 1.5 is equal to 8 minus 6.5 is 1.5. Absolute value of 1.5 is 1.5. Another question in which absolute of 4 minus x squared is equal to 2 minus x. So one time we will write 4 minus x squared is equal to 2 minus x. Another time we will write 4 minus x squared is equal to minus 2 plus x. We will take x squared on this side so that it becomes positive. X squared minus x, 4 when will be taken on this side is minus 4. So 2 minus 4 is minus 2, which is equal to 0. Now we'll solve this quadratic equation. We can take the factors of minus 2x squared as minus 2x and plus x. Minus 2 is equal to 0. X is common. X minus 2 plus 1 is common. X minus 2 is equal to 0. X plus 1. X minus 2 is equal to 0. Now we have x plus 1 is equal to 0 and x minus 2 is equal to 0. So we have x is equal to minus 1 and x is equal to 2. Now we'll solve this equation. We will take minus x squared on that side. It will become x squared plus x minus 2 and minus 4 will become minus 6. X squared plus 3x minus 2x minus 6 is equal to 0. So we have here x plus 3 minus 2, x plus 3 is equal to 0. So we have here x minus 2, x plus 3 is equal to 0. X minus 2 is equal to 0. X plus 3 is equal to 0. So we have x is equal to 2 and x is equal to minus 3. We have got three values of x. X is equal to minus 1, x is equal to 2, and x is equal to minus 3. Now we will substitute these values in the equation to check whether it is satisfying the equation or not. First of all, we will check with minus 1, 4 minus minus 1 square is equal to 2 minus minus 1. So 4 minus minus 1 square is 1. So 4 minus 1 is 3. Absolute of 3 is equal to 3. So it is satisfying the equation. Another time, we have 4 minus 2 square is equal to 2 minus 2. So 4 minus 4 is 0 here, is equal to 0. So absolute of 0 is equal to 0. Now we will check with minus 3. 4 minus minus 3 square is equal to 2 minus minus 3. 4 minus 9 is minus 5 is equal to 2 plus 3 is 5. So absolute value of minus 5 is 5. So we have x is equal to minus 1, x is equal to 2, and x is equal to minus 3. Now we have to solve the pair of simultaneous equations. We have y is equal to 3x and y is equal to absolute of 2x squared minus 5. We have to solve the simultaneous equations in the same way. We have here y is equal to 3x and y is equal to absolute of 2x squared minus 5. So in place of this y, we can write absolute of 2x squared minus 5. So absolute of 2x squared minus 5 is equal to 3x. Now one time we will write 2x squared minus 5 is equal to 3x. Another time we will write 2x squared minus 5 is equal to minus 3x. Now we will solve these equations. We have 2x squared minus 3x minus 5 is equal to 0. We will solve it by middle term breaking. So we have here 2x squared minus 5x plus 2x minus 5 is equal to 0. We can take x as common, 2x minus 5 plus 1 is common, 2x minus 5. So we have here x plus 1 and 2x minus 5. X plus 1 is equal to 0 and 2x minus 5 is equal to 0. X is equal to minus 1 and x is equal to 5 upon 2. Now we'll solve this equation. We have 2x squared plus 3x minus 5 is equal to 0. Now we can see there is a difference of the sign only, right? So it means that if this sign is negative, then we have to take this 5x as negative. Now, if this is positive, then this is to be positive and this is to be negative. If this is positive, then you will be getting positive here and you will be getting negative here, you will be getting positive here. Then we have here negative and we have here positive. So this is to be negative and this is to be positive. So we have the values of x as 1 and x is equal to minus 5 upon 2. Now we will check whether these values are satisfying this equation or not, for which we will substitute these values in this absolute equation. First of all, we will substitute minus 1, 2 into minus 1 square minus 5 is equal to 3 into minus 1. So 2 into minus 1 square is 2, 2 minus 5 is minus 3 is equal to minus 3. Absolute value of minus 3 cannot be minus 3, so this value is to be rejected. Then we will substitute 5 upon 2 in this. So we will get here 2 into 5 upon 2 square is 12.5 and 12.5 minus 5 is 7.5. And here is, well, it is 15 divided by 2 is 7.5. So absolute value of 7.5 is 7.5. Now we will check this one. 2 into 1 square minus 5 is equal to 3 into 1. So we have here 2 minus 5 is minus 3, which is equal to 3. So absolute value of minus 3 is 3. Now we will check the last value. 2 into minus 5 upon 2 squared minus 5 is equal to 3 into minus 5 upon 2. So we have here 2 into minus 5 upon 2 squared is 12.5. Minus 5 is 7.5, which is equal to minus 7, which is not possible. So we will reject this value as well. We'll write here not possible, and we will reject the value x is equal to minus 5 upon 2. Now we have two values of x is equal to 1 and x is equal to 5 upon 2. As we have to solve the pair of simultaneous equations, it means that we have to find out both values of x as well as values of y. So now we will take out values of y. We have equation y is equal to 3x. So in place of x, we will write 1. So it is y is equal to 3. Y is equal to 3 into 5 upon 2, which is 7.5. So the coordinates are 1, 3 and 5 upon 2, 15 upon 2, or we can write it as 2.5, 7.5. Now we will solve a past paper question in which we have 7 minus absolute of 2x minus 3 is equal to 0. First of all, we can take minus 2x minus 3 on this side, so it will become positive. If you take 7 on that side, that will become minus 7, and then minus and minus will be cancelled out. Now we will solve this equation. We will write 2x minus 3 is equal to 7, or 2x minus 3 is equal to minus 7. Either this can be 7 or this can be minus 7. So 2x is equal to 10 and x is equal to 5. Then 2x is equal to minus 4 and x is equal to minus 2. We will substitute these values in the equation to check whether it is satisfying the equation or not. Absolute of 2x minus 3 is equal to 7. We will substitute here 5. Minus 3 is equal to 7. So it is absolute of 7 is equal to 7. So it is satisfying the equation. Another one is 2 into minus 2 minus 3 is equal to 7. So minus 2 and minus 3 is minus 7 is equal to 7. Absolute value of negative 7 is 7. A quick recap. The modulus of a number is its distance from 0. It's always positive, whether the input is positive or negative. In mathematical terms, we can write absolute of x is equal to x when x is greater than or equal to 0, and absolute of x is equal to minus x when x is less than 0. That's a wrap on modulus function questions. Remember, solving these requires careful case-by-case consideration based on the definition of absolute value. If you found this helpful, keep practicing and revisit problems regularly. Your confidence will only grow. For more clear explanations and walkthroughs, don't forget to subscribe and support the channel. Thank you so much.